All right, good morning. Today we are working on Unit 10, that's our circle unit, classwork 03, arcs and central angles. So for our prior knowledge, what kind of triangle are we looking at over to the right? A lot of you are going to jump out and say equilateral. Remember, this is an isosceles. It's an isosceles triangle because two of the sides are the same, and notice that the two base angles should both equal 70 degrees. How does BD relate to triangle ABC? Well, BD is our perpendicular bisector. What is the measure of angle ABC? That's this one up here. Well, if the two base angles are both 70, that's 140, and we need 180 degrees, then the measure of ABC is 40 degrees, which means one of those will be 20 degrees. So that's our prior knowledge. Central angles and arcs. Figure 1 has an example of what a central angle is, while figure 2 does not. So how would you define a central angle? So this is what we're talking about. This is a central angle. This is not. So what is a central angle? A central angle is the angle that forms when two radii remember, radii is plural for radius, meet at the center of the circle. And you can see that in figure 1, but that's not happening in figure 2. A minor arc is an arc of a circle having measure less than 180. A major arc is an arc of a circle having measure more than 180, and of course less than 360. And then the circle, semicircle is an arc of a circle having measure degrees. Recall, an arc can be measured in degrees or in linear measure. So for now, we're just going to deal with these degrees. We'll come back to the linear measure, but for this section, we're going to use degree measure. The measure of the minor arc is the same as the measure of the central angle that corresponds to it. I'm going to highlight that. The measure of the minor arc is the same as the measure of the central angle that corresponds to it. The measure of the major arc equals 360 degrees minus the measure of the minor arc. So in order to prevent confusion, recall, major arcs are always named with 3 letters. the letters that detonate the endpoints of the arc and any other points on the major arc. Remember, we want to go the shortest distance. So if I was talking about arc AB, I'm talking about the minor arc, not going A and swinging all the way around to B. So here we go. If I know that angle ACB, that central angle is 50 degrees, then I also know the measure of that arc is 50 degrees. And so I know the measure of ADB is 360 minus that 50 degrees, or 310 degrees. So here, I'm going to write this out. The measure of angle ACB equals the measure of arc AB. In other words, measure of central angle equals the measure of the intercepted arc. They intercepted because it intercepts. Those radii intercept that arc. So here we go. We want to find the measure of each arc of circle P where RT is the diameter. So if RT is the diameter, PR is a chord, or not a chord, excuse me, a radius, PS is a radius, and PT is a radius. So we want to find the measure of arc RS. Well, that's 110 degrees. We want to find the measure of R to T to S. Well, we know this is 180 degrees because it's a semicircle. And so we want everything but the 110. So 360 degrees minus the 180 minus the 70 is going to be 250 degrees. Our ST going this way is 180 degrees. In this diagram, we want to find the measure of each arc. So remember, follow the letters. So G to E, that's going to be 40 plus 80. We can add those together. That's 120 degrees. G to E to F. So that's going to go clockwise. G to E to F, 230 degrees. And GF, well, if 110 and 80 and 140 are added together and subtracted from 360, we're going to get 130 degrees. Tell whether the red arcs are congruent. Explain why or why not. Well, if both these angles here towards the center of the circle are 80 degrees, then both their arcs must also be 80 degrees. So yes, both 80 degrees. Arc RS and arc TU, are those arcs congruent? Well, sure. They're both 90 degrees. Their lengths aren't the same, but their measures are the same. And same for question C. Yes, both 95 degrees. Looking at the following diagram, what is the relationship between angle ACD, that's this angle right here, and EC, ACD. I think we wanted ECB here. And that relationship is a vertical pair. So what can we say about those two arcs? We can say that those arcs are the same. Arc AD is going to be congruent to arc EB because ACD is congruent to ECB. So is there enough information then to find the value of x? Well, if these angles are congruent, then these angles must be congruent. So this must be 4x. And since they're 360 degrees in a circle, we have 4, 5, 6, 7, 8, 9, 10 x's to equal 360 degrees, which means x is 36. And we can check that. We can plug in 36 for x, and we would have 36 plus 4 times 36 is 144. 36 plus 144. We want to know, does that equal 360 degrees? Yes. It checks.